All right, so let's talk about bonds. We're done with the DCF chapter, so you should have a pretty good handle about what's going on with that chapter. But I guess this is chapter number 5 or 6. What is it?
5.
Chapter number 5, and it deals with bonds and bond valuation and different factors that affect bond values. Okay, so I'm pretty sure you've seen bonds or talking. Your professor maybe has taken talking about bonds in one class or the other. But again, let's review some bond concepts. What are bonds, and what is the mechanism behind bonds? So let's think about a simple lending arrangement, right? So let's say that you need some money to buy a house, and I have $200,000 over here. So you go to the bank, and the bank, let's say, you have pretty good credit, offers you the entire $200,000 at 5%. Okay. So in this little transaction, you are the borrower who needs money, or you're in dire need of money to buy the house. The bank is the lender. It's pretty simple, right? All right, nothing comes for free. They're charging you 5% of interest, and that's what you're paying for, again, loaning the $200,000, let's say, for 30 years, okay? So again, in this transaction, you have you as an individual who is the borrower, and the bank is the lender. What about bonds, all right? So what sort of securities are bonds? And remember, again, just like us, individuals, we have corporations who also need funding. One of the ways they can get funding is by issuing debt securities or bonds, okay? So let's say we have a company that needs, and I've made these numbers so that they're very, very simple and they're easy to remember. So let's say a company needs $1 million, all right? One of the things they can do is that they can issue, let's say, 1,000 bonds for $1,000 each to investors at large, all right? So you have 1,000 times $1,000 each and 1,000 investors, and that gives them the $1 million that they need for financing, okay? So remember, in this bond transaction, we have corporations who are the borrowers. We have corporations who are the borrowers, or they are the issuing bodies. They are the ones who are issuing bonds. They are borrowers, all right, or they're the issuers, or they're the sellers of the bonds. And then we have the 1,000 investors at large who are, the lenders. So we have 1,000 lenders versus one borrower, which is the corporation, which is, again, a little different from, when we think about going to the bank and borrowing money. Obviously, the lender is the bank, and we are the borrowers. In this case, on the other hand, we have several thousand of lenders. We have 1,000 lenders in this example, and we have one borrower, which is the bank. So, which is the corporation again. So, what are bonds again? So bonds are long-term debt instruments that are issued by corporations or government entities to finance long-term capital expenditures. Okay, so long-term capital expenditures. Corporations usually have, a couple of options. They can go to the bank and say, well, I need $3 million. They can sell shares of stock, or they can issue debt securities called bonds. So let's think about who are the parties involved. I just told you. We have on one side, we have the government entity, right? So we have heard of treasury bonds. I'm sure we'll talk briefly about it. And corporations who are the borrowers. So they need the money, right? So they're also called issuers or sellers of the bond. And then on the other side, we have investors such as you and me, or financial institutions who are the lenders, or also known as bond holders, right? So we are loaning the money, not individually, but collectively. A lot of us are loaning the money. So we hold the bond, we're the bond holders, we're also the lenders. So everybody, whenever they invest, they command or they want some sort of return. So what do bondholders get from the lending arrangement? Okay, so they get two sets of cash flows. One, coupon payments that occur normally every 6 months. Coupon payments. And finally, they also get what's known as a face value, which is typically $1,000 at maturity when the bond matures. So they get the coupon or the interest payments, coupon, normally every 6 months. Most of the time 6 months, unless it's an annual coupon paying bond. And then they have the face value, which is again typically $1,000 at maturity. So a couple of things I have over here. The coupon rate that is normally quoted in Yahoo Finance or on the bond contract is the interest rate on the bond used to calculate the annual cash flows. Right? And I'll give you the formula for that in just a second. And then we have the face value, usually $1,000, that the lender or investor receives at maturity. So if you look at a 20-year bond, the 20-year bond looks like this. So you have year 1, 2, 3, 4, 6, 20. Annual coupon paying bonds, you can see all the coupons are fixed. And then you have at the end when the bond matures $1,000 face value. Again, as I just told you, we have bonds normally pay coupon payments every 6 months. So if it is semi-annual, we have a situation like this. Coupon divided by 2, coupon divided by 2, coupon divided by 2, and still we have the $1,000 at maturity. So how do we calculate these interest payments? All right, so the coupon payment is nothing but the coupon rate, whatever it is, 4%, 5%, 6%, 10%, times the face value. Remember, face value 1,000. Face value is also known as the par value. The book uses it interchangeably. So face value or par value, so you have the coupon rate, whatever that might be, times either the face value or the par value, they're the same, to calculate the coupon payment. They're fixed throughout the life of the bond, as you can see, and so is the face value. It's $1,000 by definition. All right, we go down, we have another example from the book. Let's say we have X corporation has issued a 10-year bond, I guess it's assuming annual, 8% annual coupon. The cash flows from the bond would be paid as follows. So you have 80, 80, 80, 80, and then a final $1,000. So where are these 80s coming from? So we have the coupon rate, remember, which is 8%. And we take that 8% and multiply that by the face value again, which is 1,000. So 8% times 1,000 is going to give you $80, so you get $80 every year. And then finally you have the last cash flow, which is the face value at maturity. So don't forget to add back the face value, because that's something that you also earn from the bond no matter what happens. You have to add that back as well at the very end. So again, 2 sets of cash flows that lenders receive. Again, we are the lenders, investors, financial institutions are the lenders. Coupons every year, every 6 months, and then finally we have the face value at maturity. So how do we find, there are 2 things we need to learn in the bond valuation chapter other than the different kinds and the characteristics of bonds. That is, number 1, how to calculate the present value of the bond, and number 2, how to calculate the yield to maturity or the rate of return you would earn from the bond if you held it till the bond matured. Okay, so let's try to find out how to find the present value or the price of the bond. Okay? So this is the formula, all right? Present value of the bond is nothing but the present value of all the future cash flows, future expected cash flows again, the bond is supposed to generate throughout its lifetime. Okay? So we have that formula over here. I also have that formula somewhere else. Let me just open that up. Have that. Okay. I guess this will have to do. Read. All right. So this is telling you that the present value or the fair value of a bond is nothing but the present value of all its coupon payments and the present value of its face value or par value at maturity. So that's again the DCF principle. The DCF talks about what's the price of any asset. It's nothing but the present value of all the cash flows that asset is supposed to generate throughout its lifetime. And I just told you, if you invest in a bond, there are 2 sets of cash flows. Coupon payments, and then finally we have the face value of maturity. Therefore, the present value of a bond is nothing but the present value of all the coupon payments, depending on what is the life of the bond when the bond matures, and then the present value of the face value as well. Okay. So if you want to use the formula, that's the formula. We have the annuity formula, but of course we also have to factor in the face value, which is $1,000, and we find the bond value. Okay. If we use our calculator, what do? And we will come back to that. So let's do a couple of bond problems. We will do a few. All right, the first one says, what is the price of a 6.5% annual coupon paying bond with a $1,000 face value which matures in 3 years? Assume a required return of 3.9%. Okay, so there are 2 percentage signs, which might be confusing to some, but it's not very confusing. When it says 6.5% annual coupon, you automatically know that number is going to be used to calculate the coupon payments. 3.9% required rate of return, that's the R, and that's the rate of return that's going to be used to calculate again for discounting. So we have the coupons, and then we have the R. This is the discount rate, and these are again the coupon rate. Coupon payments are going to be calculated based on the coupon rates. So let's try to solve this. First of all, let's figure out what our coupon payment should be. So I just told you coupon payment is nothing but the coupon rate times the face value. So what should it be? 65. All right, everybody sees that? It should be 65. 6.5% of 1,000. Very good. That's 65. What do you think our $1,000 should be? What is our $1,000? It's the future value because we are receiving it when the bond matures in the future. So it's the future value. Okay. 3.9% is our I by Y, or the rate of return. So we have payment. We have payment at 65. We just determine that. 1,000 as our future value. 3.9 as our I by Y, and finally N as 3 years. Okay. So let's go down. So we have 65 payment, 1,000 face value, future value 3 and 4 I by Y, and compute PV. Because again, the price of any asset is the present value. So we're trying to find what the price is. And we find the PV, and it turns out to be 1072, I guess. So not very many inputs in the bond calculation, remember. So we have, again, coupon payments, you have to remember that, calculate that. You know, you can do it in your head, I'm pretty sure. $1,000 face value, and I by Y, and compute the present value. All right, we go down now, and we look at some rules, or go up actually. So these are some rules, the book talks about it, and therefore I have it in my lectures. It says when the coupon rate is greater than RR, or required rate of return, or this is greater than that, all right, and you don't have to memorize it, just you know, it is easy for you to read them and understand them and tackle the problems on your test. The bond is selling at a premium, okay, which means that it's selling for more than the face value, which means that it's selling for more than 1,000. So, all right, in this case, this is true. 6.5% is greater than 3.9, and the answer we got was 1,072. And we see that, well, yeah, it is selling at a premium. It is greater than 1,000. Conversely, we have when coupon is less than RR, bond is selling at a discount, and therefore the present value of the bond is going to be less than 1,000. And finally, when the coupon and the required rate of return are the same, so we have 6.5 and 6.5, the bond should sell at par, which means you don't even have to do the calculation. Present value of the bond is going to be $1,000. Okay? So I have a couple of examples here. What is the price of the bond if the required rate of return is 6.5%? Well, I just told you, if you do the calculation, it's going to be very close to 1,000. What if it is 15% and we get a number which is less than the face value, 805.93? So a very simple bond calculation. Again, you have the coupon payments, which are again annuity payments or PMT, face future value and I by Y, and you can calculate or solve for the present value. All right. Normally we have bonds that are paying coupon every 6 months, and we have to make some adjustments for that. So let's do the same problem. All right, let's do the same problem, and let's assume that it's a semi-annual coupon paying bond. I'll make the numbers a little better. Let's do semi-annual bond, and this is not annual. Let's do this in class. Semi-annual coupon paying bond. All right, this is for, let's do this 20 years, and let's try to find out what the price is, okay? So it's a semi-annual coupon paying bond, and therefore there has to be some changes. What are some of the changes? Oh, it's 8 of 1, that's great.
Coupon rate?
All right, so coupon rates are actually the payment.
Payments, 40 payments.
All right, so, all right, what is the payment, first of all?
65.
Okay.
And
But-
Is 40 instead of 20.
37.50.
Okay, I like that. It is 37.50 because it's semi-annual again.
Right, yeah.
All right, what is that?
37.50. 32.50.
I'm getting different numbers, guys.
It's
It's
32.50.
32.50.
Okay. All right, N is what again? 40? Okay. What else is there? 1,000 future value. Are we missing anything else, guys? What are we missing? Okay, and what is the I by Y? 2, okay? And we compute present value. Tell me what the number is. So is there anybody lost? I know it is very late. It's also a very, very long day for me. The present value should be more than or less than $1,000. Remember, the coupon rate is greater than the required rate of return, so you should assume that the bond is selling at a premium, so it should be more than 1,000. So what is the answer?
1,341 and 94 cents.
Is that right, guys?
Yes.
Where am I? And the yield to maturity is the rate of return from a bond, if and only if you hold the bond till maturity. Okay? So the yield to maturity, or R, is the rate of return that you earn from the bond only if you hold the bond till maturity. So let's say it's a 10-year bond and the yield to maturity is 10%. So the yield to maturity means that only if you hold it for 10 years, the rate of return is going to be 10%. If you hold it for less than 10 years, it could be more than 10% or it could be less than 10%, depending on what the market value of the bond is. Okay? You know, just realize this. For bonds, all the cash flows are certain, aren't they? So we will look at bond quotes next time. But when you buy a bond, you know, bond are fixed income securities, and all the cash flow associated with the bond, the coupon rate is going to be the coupon rate, coupon payment is going to be the coupon payment till the bond matures. Face value by definition is 1,000. So we don't really have any uncertainty at all, right? The only uncertainty is if you want to sell the bond before it matures. So let's say, you know, you invested in a 30-year bond, and you know you have, at the end of, let's say, 10 years, you have some other competing investment that you are more interested in. You don't want to keep this bond anymore because you're earning, you know, substantially a much higher return in another competing investment that you have, that you're thinking about. So you might want to sell the bond. You know, a lot of people don't like 30-year commitments. You know, a lot of things happen over 30 years. I'll show you next time how interest rates have behaved over 30-year or 40-year time spans. You know, interest rates can be quite erratic. So the rate of return changes again. Your rate of return will change if you decided to sell the bond before it matures. And that would be dependent on what the market value or the current value of the bond is at that point in time. So for a 30-year bond, you know, is the market value higher or lower than the present value? And that's going to determine again what the rate of return is going to be on your investment. So again, yield to maturity is the rate of return if and only if you hold the bond till the bond matures. Okay? All right, example of yield to maturity, we'll do a semi-annual and we're going to do an annual. So we have over here, can you see at the back, is it too small or is it okay? All right, we have what is the yield to maturity of a 6.5% annual coupon paying bond, $1,000 face value, which matures in 3 years. Market price is $1,072.29. Okay, so we have to calculate I by Y now, and we are given present value, future value, and the coupon payment. Okay, so how do we set this up? We set it up like this. So we have again our coupon payment is 65. Present value, again, as I told you, when you have the present value and the future value in the same equation, you have to assign a negative sign. So the present value should be a negative sign. Future value is 1,000, n is 3, and we calculate I by Y. So not very difficult really, other than remembering our present value should be a negative number because it's a cash outflow. That's the price that you're paying for the bond. You get all these 65, 65, 65, and you have the $1,000 face value that affect bond prices. All right, before that, we talked a little bit about current yield versus yield to maturity. Okay, so what is the difference between current yield and yield to maturity? Well, current yield is nothing but, so let's write CY. So CY is nothing but annual payment, annual PMT, divided by the price of the bond, or the market value of the bond. While yield to maturity, you know what the yield to maturity is, the rate of return after taking into consideration all the cash flows of the bond. Okay, so if it's a 30-year bond, it'll have 60 plus 1 cash flow. If it's a 3-year bond, it'll have 6 coupon payments plus 1 cash flow. So that it takes into consideration all the cash flows. That's the entire rate of return. That, on the other hand, current yield is nothing but annual payment, so payment for 1 year, divided by the market value. So it shows you, what are the annual payments as a percentage of the current price of the bond. It's kind of like the dividend yield, okay? But they're different though. So when I ask you what is the current yield, what you do is take the annual payment divided by price. When I ask you for the YTM, you use your calculator or the approximate formula that I've given you and calculate the yield to maturity. So they are different though, and they measure different things. That, as you can see over here, these are just the annual payment, just one annual payment. That yield to maturity takes into consideration all the cash flows of the bond. Okay? The next item we have is what are some of the factors that affect bond values or prices. The first one is interest rate. All right. So what do you think is the relationship between interest rate and bond values? Bond values and interest rate. Increases in interest rate has a negative impact on all asset values. Okay. So if interest rate in the economy goes up, asset values go down. Interest rate go down, asset values go up. And that one of the ways you can remember that is by looking at the discounted cash flow valuation model that we talked about. Let me see if I have it. There it is. All right, so this is our basic valuation model. Remember, this tells you that the value of any asset is nothing but the present value of all the cash flows that it's supposed to generate throughout its lifetime. So if you look at this equation, R goes up, obviously the present values go down, and so the value of the asset goes down. R goes down, the present values go up, and consequently, value of the assets also go down. So that's what you can see very, very easily mathematically. Okay? So obviously, when we look at this, all right, so R goes up, all right, R goes up in the economy, and the YTMs, bond rates are determined by what the price are in the prevailing economy. To some extent, we have R goes up, present value of these cash flows go down, PV go up, or PV go down as well. R goes down, all right, present value of these cash flows go up, and PV goes up again. Okay, so that's number one factor, interest rate, of course. Okay, what is the second factor? We have time remaining to maturity. Okay, coupon and required return kept constant. Time remaining to maturity, or time to maturity, let's call it. When we compare two bonds, all right, one with a short maturity and the other with a longer maturity, we will see that the longer maturity bonds are more price sensitive. Okay. They're more price sensitive. That means they're more affected by changes in interest rate, either positive or negative. So again, longer maturity bonds are more price sensitive than shorter maturity bonds. Okay, so I have a little chart from another book. Let's look at that chart. So I mean, you don't have to memorize the numbers or anything like that, but this is just for illustrative purposes. Okay. So why are longer maturity bonds more sensitive? I don't know why they use 16 and 12. I would use 30 and 3 or something like that. But let's look at this 12-year maturity bond, okay? When interest rates go up from 8 to 10%, the price of the bond should go down, right? All right. So interest rate goes up from 8 to 10, price of bond goes down from 1152 to 1,000. That's a change of about negative 13.2%, okay? Interest rate goes up more, 10 to 12%, bond prices go down, and this time by negative 12.55%. So again, we're looking at percentage change, or this chart is looking at percentage change, and it's just saying that when interest rate goes up, bond prices go down. For the 12-year bond, 8 to 10% change, decrease the bond price by 13.23%, 10 to 12% increase, decrease it by 12.55%. All right, so that was a 12-year maturity bond. If you look at the 16-year maturity bond, we see that, well, it is more price sensitive because when, again, interest rate went up by 8 to 10%, that bond value reduced by 15.16%, which is more than that. And when it went up from 10 to 12, it decreased by 14.08%. So again, it's just telling you that, again, longer maturity bonds are more price sensitive. That means they decrease more, and also conversely increase more when interest rate changes over time. Okay, because again, there are more cash flows at stake. All right, so I want to show you a chart. All right, so why would that be? All right, why would that be? Why are longer maturity bonds more price sensitive? Well, first of all, again, I don't like 12-year, 16-year. Let's think about a 2-year bond, and let's think about a 30-year bond. Okay, so we have a 2-year note and a 30-year bond. So, I mean, just by thinking about it, if you just think about it from your general knowledge, you would say that, well, the 30-year bond is probably much more price sensitive. The 30-year bond would probably be, more affected by changes in interest rate. Why? number one, there are more cash flows at stake. All right, how many cash flows, assuming it's a semi-annual bond, how many cash flows does a 30-year bond generate?
60.
Is it 60? It's 61 actually. So there are 60 coupons and then one face value. Okay. So 61 cash flows. Similarly, a 2-year note is going to generate 2 times 2, 4 plus 1, 5 cash flows. Okay. So a 30-year, 2-year. I like that example more. Let's think about that. I thought I had this open, but I guess not. Let's look at this graph over here. You might have seen it before. This is from Fred, which is the Federal Reserve of St. Louis, not a male friend that I know or anything, but it's from Fred. I'm pretty sure you've heard of Fred. And I just plotted this, but this just shows you how 1 year, 5 year, 10 year, 20 year, and 30 year, and not 20 year, but 30 year Treasury bonds, how they behaved over time, all right? So from 1962 all the way to 2010. So as you can see, interest rates have been quite volatile. If you look at this, we have a peak over here, 1981, at about 14.8%, okay? So that means the savings rate was on average about 15%, but mortgage rates were also 15%. It was kind of a time when inflation was also pretty high. So it's not that, well, you're just investing at 15% and getting a 30-year return. That's not necessarily true. But when we were talking about price sensitivity between a 2-year versus a 30-year bond, think about it. A 30-year bond, over 30 years, interest rates can go haywire. You can see that, right? So, of course, the market value of a 30-year bond would be affected, more affected, because, again, the interest rates are going haywire. But if you think about a 2-year note, and if you splice this graph up, and if you look at just 2-year, 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 we see that not a whole lot is going on over 2-year periods. I mean, normal 2-year periods, not a whole lot is going on. So that's one of the reasons why, again, your 30-year bond may be a little bit more price sensitive, because interest rates go haywire over 30-year period versus, again, 2-year periods. Another reason is I was just telling you, you just have too many cash flows that you're discounting versus a less number of cash flows that you're discounting. So number one, we had interest rate, and number two, we had time remaining to maturity. And number three, we had coupon payments, and we have the higher the coupon rate of the bond, everything else constant, the less susceptible they are to changes in interest rate, all right? And we have, imagine two bonds, one pays $50 coupon, the other $5, all right? And the $5 bond, of course, is going to be more sensitive to interest rate changes, holding everything else, again, constant, okay? So, issuer's default risk. So, one of the ways that we evaluate the riskiness of a bond is by looking at bond ratings. And I'm sure you might have looked at it in 505 or some other finance class that you have taken. But one of the ways, or an important way you can assess the riskiness of a bond is by looking at bond ratings. So bonds are rated by issuers' default risk. And let's look at, we have three major rating agencies, I would say. There are many others, but the three are Moody's, S&P, and the book doesn't really talk about it, but Fitch. Fitch is also highly quoted in the media and very, very well known. I'm sure you've heard of Fitch. So let's look at their ratings. We have best quality, lowest degree of risk, okay? AAA. Highest quality, slightly more long-term risk. AA plus, then we have AA. And then when we go to B, we have B and C and G and CAA. They're all speculative investment grades. That means that the cash flows of these companies are not very certain, and the bonds are kind of very, very risky. Okay, so you have all the way from very, very low risk to very, very high risk. So what can you see from the bond? Let's look at the bonds. Okay, so we have the higher the rating, the blank the risk. So the higher the rating, the blank the risk. Lower the risk, right? So the higher the rating, the lower the risk. And consequently, the blank the yield. Can you write this down if you don't mind? So the higher the rating, all right, the higher the rating, the lower the risk, and consequently the blank the return. Lower the return, right? So we have on one side we have AAA bonds. They're the amount of risk, the very low risk, and consequently very low return. If we look at the other end of the spectrum, we have the C bonds, and you know the lower B bonds, and they have comparatively much higher risk, low rating, higher risk, high return. Okay, low rating, high risk, high return. High rating, low risk, low return. Okay, so just write that down. It might be on your multiple choice, or just for your general knowledge. We will look at what's known as the term structure of interest rates. Did everybody get that? So I said again, a lot of you already know that the higher the rating, the lower the risk, the lower the yield or return. Lower the lower the rating, the higher the risk, and consequently the higher the return. Okay. So I want you to look at what's known as the term structure of interest rate. Okay. So what is the term structure of interest rate? It's a graph. Okay. But what does the graph tell you? See, we have yield and then we have maturity. What is this graph telling you? Yield and maturity. So the term structure of interest rate is talked about, if you go to CNN Money or Yahoo Finance or CNBC, they talk about the term structure. And any ideas about what it is? Alright, so it's just a graph. It shows you the relationship between the maturity of a bond, a treasury bond, and the yield of the treasury bond. So we have maturity on one side and then we have yield on the other. It's upward sloping. So what does it mean? What is the implication? What does upward sloping mean? What is our positive relationship between what and what? Alright, so it just tells you the longer the maturity, the higher the yield. Alright, longer the maturity, the higher the yield. Okay, so in other words, a 30-year bond should offer a higher return than, let's say, a 5-year bond. Why? 30-year bond should offer a higher return than a 5-year bond. Why? What is it? Wabe said something?
There's more risk with the 30-year
Are
bond.
more risk involved? We just looked at the interest rate risk, right? We said the interest rate risk was very high over 30-year periods versus 5-year periods. I mean, again, we have to assume that they're normal periods. The 5-year could be a very, very chaotic period, But 30-year bonds again. And that's known as the maturity premium. Remember, so longer maturity bonds command a higher return, and in comparison to shorter maturity bonds, and that's known as the maturity premium. Right? The maturity premium, right? The premium that you as an investor command in the market for holding an instrument that is, let's say, 30-year versus 5-year. Because again, a lot of people don't really want to invest like that, like me. They don't want to invest in a 30-year bond. It's too long for them. Okay? So yeah, 5-year fine, even 7-year fine, but 30-year may be a little too much for a lot of investors. So to give them some sort of an incentive, they offer a high return. Bonds have to offer what's known as a high return. So we have that yield curve, that it shows you the relationship between the yield of a bond and the maturity of a bond. Longer the maturity, higher the yield. Shorter the maturity, lower the yield. And of course, we know that longer maturity bonds are much less liquid because there are not too many people who want to invest in that than shorter maturity bonds as well. Let's look at one thing before we talk a little bit more about this, and that's known as the Fisher effect. All right, do you remember about the Fisher effect? What is it? I'll just write down the shortcut formula. The shortcut formula, the approximate formula is that real rate of return equal nominal rate minus inflation. Okay, real rate equal nominal rate minus inflation. It's just telling you that, well, the real returns are important because, we might have a 20% nominal rate. All right, that's our rate of return. Let's say we invested somewhere, it's 20%. But let's say we live in a very high inflationary period, and the inflation in that year was 15%, and our real return is actually 5%. That's how much we made. So Fisher's theorem or Fisher's equation is very important because it tells you that inflation is very important. Now, if you're living in a high inflationary period, yeah, your 30% return might not really have any value. But if you're living in a low inflationary environment, let's say your 10%, let's say it's 1%, 10% nominal return might have more value. Okay. So know this equation, real rate, approximate formula. Real rate is approximately equal to nominal rate minus inflation. Okay. And why is, again, inflation looks at what your purchasing power is. So we need to factor in inflation when we're calculating return, because that's going to tell us how much can we really buy, how much earning power, earning potential does my return really have. Okay, so that's very important. Let's go back to our chart now, which was the term structure chart. And we looked at this, and if you look at this chart, I don't know how well you can see it from way back, but this is in nominal terms. Okay, so this is your yield curve in nominal terms. If you look at this as nominal and real. Okay, so this is